Welcome back, ladies and gentlemen. Welcome to our practice test for test number 6, roots and radicals. This is our day 1 part. So I'm going to make 2 videos, one on day 1, one on day 2. So let's get rolling. Okay, so it says simplify the following expressions. I have 2x cubed root of 135x to the 5th y squared z. Just trying to focus for you guys. Cool. Okay. You are looking for the perfect cube that can go into 135. Now, we are going to have these on, the board for you guys, 1, 8, 27, 64. So, we keep 2x chilling out front. The perfect cube that can go into 135 is 27. And that can go in 5 times. So I'm breaking this apart, just like you guys did with square roots. The next thing is this, and you guys are very good at it. How many times can 3 go into 5? It can go in once, so I can pull out an x to the first, and the remainder is 2. So I keep 2 under the cube root. Okay? How many times can 3 go into 2? Well, I can't go in at all, so I just leave the 2 underneath there. Okay? And then finally, how many times can 3 go into 1? All right? Not at all, so I keep it cube root of just z. Awesome. Alright guys, so this is the first step. After this, we now look at what we've got. This right here, the cube root of 27 equals 3. Okay, so what we can do, if you really want to double check that, I got my graphing calculator. We hit the math button, down to number 4, says cube root 27. If I hit enter, boom, there it is. So, we've got 2x times 3 times x, okay, and everything else stays under the cube root. So the 5 stays under the cube root, the x squared, the y squared, and the z. So finally out here, what is 2x times 3 times x? Well, 6x squared, and everything else stays under here. And then you can give yourself a high five because you win. Okay? 1 down. There's only 6 problems on the first day. Alright, over here, number 2. This is the exact same thing as the first one, except as you notice, there's a plus sign here. If on the test it was a minus, you would just subtract it. But let's see if we can break this down. I've got 5y, cube root, 2x to the 5th, y to the 4th. So, 5y. Can I find a perfect cube that goes into 2? Hopefully you guys are thinking no. Okay, so that stays 2. Can 3 go into 5? It sure can. I can take 1 out. What's your remainder? 2. Can 3 go into 4? Yep, once. So I can pull 1y out. What's the remainder of 1? Okay. Awesome. Now over here, plus, you got that x chilling out front. Okay. Is there a perfect cube that can go into 16? Well, again, here are my perfect cubes off to the left. Hopefully you guys can see that 8 goes into it. So I've got the cube root of 8 times the cube root of 2. Okay, how many times can 3 go into 2? Can't, so it stays underneath there. How many times can 3 go into 7? Twice. I can pull out 2. Okay, and then I keep it cube root of y. Alright, play a little cleanup. Over here, 5yxy gives me 5xy squared. Okay, and then I have that cube root of 2x squared y plus. Alright guys, I'm going to do one little step here. The cube root of 8 is 2. So I'm going to pull out a 2. There's an xy squared there. And then what's left underneath the cube root is 2x squared y. Okay, question for you. Is this the exact same thing as that? xy squared cube root 2x squared y? You bet. So, now I can add these things on the outside. What's 5 plus 2? 7. And everything else stays exactly the same way. Okay, all good. That problem's an endurance, yes. It's just about keeping things organized and you're good. These should match up. Okay? If not, double check your work, make sure you're good. Okay, down here for number 3. So this one looks super scary. It's actually very nice and easy as long as you just keep things simple. Everything's under the cube root, okay? So look at your numbers first, 15 over 40. What number can go into both of them? Hopefully you guys are thinking 5. So if I divide the top by 5, 15 divided by 5 is 3. And then down low, 40 divided by 5 is 8. Cool. Alright, I have x to the 10th over x. So if I do 10 minus 1, I get x to the 9th. I have 1 y on top, I have 7 y's on the bottom. If I take 1 away from the top and 1 away from the bottom, I get y to the 6th down here. Okay. So up top, what I've got is the cube root of 3x to the 9th. Can I take the cube root of 3? I cannot. How many times can 3 go into 9 though? 3 times. So pull out x to the 3rd. What is the cube root of 8? 2. What's the cube root of y to the 6th? Well, how many times can 6 divided by 3? Twice. Done. Okay? Keep things simple, and that problem is very easy. Okay? This is the hardest section of the entire test. This is the grind, alright? So I will give extra practice problems on it if we need it. Okay. Down here, things get a little simpler. I want to solve for 5x to the 2/3 minus 11 equals 114. Okay. Just like we do in class. Get the x by itself. Add 11 over. Okay. Alright, I gotta get rid of that 5. Divide by 5. X to the 2/3 equals 25. Okay. Now, I'm going to raise both sides to the 3/2 power. Okay. So if I take my calculator, and I've got 25 raised to the 3/2. If you have an old calculator, make sure you put parentheses around it. So I get 125. Now here's one thing for you guys. Can you guys see the bottom number here is a 2, which means I'm technically taking the square root of this. What must we always put out front if we do an even powered root? Plus or minus. So my final answer is x equals plus or minus 125. Okay. Guys, just a heads up, if on the test this is an odd number on the bottom, you do not need the plus or minus. Alright? Good. If we were to plug this back in, okay, so just real quick, I got 5 parentheses. Let's do 125 first. Raised to the 2/3 power. Minus 11. Does that give me 114? It indeed does. And if I wanted to put in negative 125, okay, second insert negative, that's still going to be 114. We win. High five. Alright. Number 2. Subtract 11 first. Hopefully you guys are noticing a trend. 3 parentheses 5x minus 1 cubed equals 203 minus 11 is 192. Okay. I can divide everything by 3. So that should give me 64. Cool. Okay. Keep things easy for yourself. How do I get rid of a cubed power? The opposite of cubing something is to cube root it. Okay. So that cancels this out, and I get just 5x minus 1 equals, what's the cubed root of 64? What number times itself 3 times gives you 64? 4. Because this is an odd powered root, I don't need plus or minus. Okay. If I add 1 over, 5x equals 5, divide, x equals 1. Alright, quick check. So it goes 3 parentheses, 5 times 1, minus 1, raised to the 3rd, plus 11. 203. You're all good. Okay? Alright, good so far. Last one here. Okay? Okay, so last one here. I have the square root of x plus 8 equals x minus 3. This is that difficult one I was talking about in the notes the other day. You want to square both sides. When you square a square root, you get just x plus 8. Cancels everything out. You need to FOIL this. Now, I'm going to go ahead and show the work over here. I'm hoping by now you guys are getting comfortable with FOILing. Okay? So x squared minus 3x minus 3x plus 9. So that's going to turn into x squared minus 6x plus 9. Cool. Now, I'm going to have to subtract x over, subtract x over, subtract 8 over, subtract 8 over. So x squared minus 7x plus 1 equals 0. Now, I will let you guys know this. I apologize. I made this review up fairly quickly. So this right here is unfactorable. There are no two numbers that multiply to give you 1, but then, add up to give you -7. So in this case, I'm going to have to use quadratic formula. The one on the exam should be factorable. If not, we can always fall back to this formula. Negative of -7 is positive, plus or minus square root. -7 squared minus 4 times 1 times 1 all over 2 times 1. So we're looking at 7 plus or minus square root. -7 squared is 49. 49 minus 4, sorry. So 7 plus or minus square root of 45 over 2. Okay, what perfect square goes in 45? You guys can definitely handle this now. 7 plus or minus root 9 times root 5 over 2. So that would be 7 plus or minus 3 root 5 over 2. Okay? And again, if on the test, this should right here be factorable. Okay? But quadratic formula isn't that bad. You just plug things in and go. So that is your first day of the test. Is there a lot? Well, the bottom right here is definitely a lot easier. Okay? It really is. Up top, yes, this is a lot. Okay? This is why we need to study. This is why we have to take time to study. Okay? Know your properties and you'll be just fine. So, as always, keep up the good work. Good luck. We're all counting on you.